Hello everybody, welcome back to my channel. Today is the second video regarding homogeneous differential equations. So it is a type of differential equations which exist in a form of P by Q form, in which the degree of the numerator is equal to the degree of denominator. So what we need to do, the method to solve a homogeneous differential equation is to let y is equal to vx and you take a derivative. Ultimately, we reach to a form that's pretty much similar to variable separable. So this is a question which we are going to solve. So yes, there we are. It says x dy by dx minus y multiplied by tan inverse y over x is equal to x. So let y is equal to vx, which proceeds as dy by dx is equal to v plus x dv by dx. We need to apply product rule over this whole thingy. So what we're going to do is we're going to plug the whole thing right in here. So it is going to be, so yeah, what we're going to do, yeah, we're going to plug in here. So x is going to be y over v, v plus x dv by dx minus yx, vx, tan inverse vx over x is equal to x. It leads us to a state, and this thing can be taken outside, ultimately dividing both sides by x. So that's going to yield something like y over v plus dv by dx minus v tan inverse v is equal to 1. This term is cancelled. So ultimately we are left with something as y over v is equal to x dv by dx tan inverse v is equal to 1. This x is going to move towards the right hand side, so dv by dx tan inverse of v is equal to 1 over x. Now this thing is going to move towards this side, so we're going to yield with something as dv tan inverse v is equal to 1 by x dx. We need to apply integration on both sides, so tan inverse of v dv is equal to 1 over x dx. Now the right hand side can be easily solved, but we need to apply integration by parts on both sides, on the right hand side. Which is stated as of x v of x dx is equal to, first function remains the same, second function is integrated, dx minus dt. This function is again integrated on this side, dx d by dx f of x. So if the tan inverse v is existing here, so this means that there's another term 1 multiplying with it, because it's not playing any dominant role. So there's a rule that is a famous rule, ILATE, which states as inverse logarithmic algebraic trigonometric and exponential. This is the trend to solve to use integration by parts. So priority is given to tan inverse v as its inverse function, and yes, it is going to be the first function f of x. So yes, tan inverse v 1 dv minus 1 dv d by dv tan inverse v. Now this thing is equal to natural log of x. So v tan inverse v minus v 1 over 1 plus v square dv is equal to natural log of x. Natural log v minus v over 1 plus v square dv. Now what we need to do is that we need to multiply and divide both this thing by 2. So v tan inverse v minus 1 by 2 2v 1 plus v square dv is equal to natural log of x. So the thing is, it's a well-known formula that integral of derivative of function over function dx is equal to natural log of x. So in this case, it's going to be in v tan inverse v minus 1 by 2 natural log 1 plus v square is equal to natural log of x plus natural log of c. Now basically what we can do is that we can combine this term together, and yes, first of all we need to indicate this term 2. So multiply both sides by 2. 2v tan inverse v minus natural log of 1 plus v square is equal to natural log of xc into 2. So this is going to be yeah, so it can still be solved in this way as 2v tan inverse v is equal to 2 natural log of xc plus natural log of 1 plus v square cancelled. V tan inverse v is equal to natural log of xc 1 plus v square. Yeah, this is also a good solution, whereas this one is also a solution. This one is also a solution. And yes, I forgot to mention something where v is equal to y over x. See, I forgot to mention this thing. This is pretty important. Yeah. So this is a question which we have solved.